This is flip number 1 for chapters 17 and 18. Chapters 17 and 18 are all about air pollution and climate change. First of all, I'd like to talk to you guys about the atmosphere and how the atmosphere is pretty much analogous to the skin on an apple regarding its thickness in relation to the size of the Earth. So the atmosphere is really thin. It's a real thin layer of gases, as you can see here on the slide, that envelops the Earth. Um, it's held close to the Earth because of gravity, and the major gases that we find in there are nitrogen, oxygen, argon, and carbon dioxide. So the most abundant gas here is nitrogen. And then we also have a little bit of methane, ozone, hydrogen sulfide, hydrocarbons, CFCs, and water vapor. Um, so when I read these slides, it's actually, you guys should be like writing down these notes as well. Um, just the main points. You don't have to write it word for word. Um, the atmosphere is made up of different spheres. So if this was the Earth, the atmosphere would be a very thin layer above it. But what I'm going to do is not draw it to scale to show you the different layers. So the layer closest to the Earth is the troposphere. The next layer up is the stratosphere. The next layer up is the mesosphere. And finally, the thermosphere. In some books, after the thermosphere, they have the exosphere, but we don't need to get into that. So each of these layers varies in their distance from the Earth and how thick they are and what they're made up of. The troposphere is definitely the most diverse with gases, and that's because of gravity. Gravity pulls those gases toward the Earth, but also the fact that the troposphere is in direct contact with the life on the Earth and the different types of cycles that occur on the Earth that have a gas phase as part of it. So all life on Earth is pretty much a pumper of gas, where we're taking in gas and giving off gas. Um, it's kind of funny. So the troposphere varies, and it's very diverse. The troposphere will extend up into the atmosphere to an altitude right around 30 kilometers. But that's always changing. That's important to know because the gases change, and it also depends on where you are on the Earth and because of the spin of the Earth and the pooling of the gases. So here's the Earth, and the Earth rotates, and as it's rotating, the gases tend to flatten out at the poles. So the atmosphere at the poles is really thin in comparison to the atmosphere around the equator, just to make it simple. The stratosphere is the next one up, and the stratosphere is the ozone layer. The ozone layer varies in altitude as well, but generally speaking, it is anywhere from 10 to 16 miles above the Earth. And the stratosphere's ozone layer that's there helps shield the Earth from harmful ultraviolet radiation. It's important to know that when the sun shines on the Earth, that a lot of this radiation that comes in bounces out back to space. That's a good thing. And that's because if it absorbed all of this radiation, all of this solar radiation, the Earth would be much warmer than it is. This bouncing back out to space off of ice, if you remember from the beginning of the year, is called albedo. And now we do know that there's less ice today for the amount of time that it used to be around. The ice sheets up in icebergs up in the North Pole and in the South Pole um, are melting fast and they are thinning, and in some cases new shipping channels and new shipping routes are being created as a result of less ice. So honestly, shipping has improved because ships are able to move goods from Russia and Europe over to the United States really quick for a longer shipping season due to less ice cover and or thinning ice, which makes it easier to go through with the ship. Um, and since there's less ice, that means there will be less albedo. And as a result of that, then this solar radiation indeed is getting absorbed into the Earth, specifically into the ocean. And we call this thermal expansion. Doesn't mean it's boiling. It just means that it's a higher temperature than usual. And as a result, that heat energy is expanding throughout the oceans. The next layer up is the mesosphere. And you don't really need to know much about that. And then the thermosphere. And this is all on page 418 in your book. So you can reference that. Okay? Um, so this is stuff I just went over. The troposphere is around 11 miles up. Again, that varies. And it's only about 5 miles above the poles. Like I say here, that's because of what I was talking about over here with the spinning of the Earth and how those gases get pulled. The stratosphere is the second layer up. Um, in this slide, it says 11 to 30. In your book, it says 10 to 16. Again, it varies. And that's simply because of the amount of ozone that's being destroyed / what's being formed and where you are in the atmosphere above the Earth. So we learned that the stratosphere helps to protect us from the harmful UV radiation. Now, two really important global processes that occur in the atmosphere that allow us to live on the Earth are the greenhouse effect and the ozone layer. It's a process, what it does. So with the greenhouse effect, here's the Earth, here's the sun, here's our atmosphere, and um, here's incoming solar radiation. Again, a lot of that bounces back out because of albedo, but then it's also important to know that some of it's trapped, so not all of it gets reflected back out to space. Some of it gets trapped, and it's because of this layer here. This is the atmosphere. And in the atmosphere, there are greenhouse gases. And these greenhouse gases, you need to know, are like water vapor, carbon dioxide, ozone, methane, nitrous oxides, and CFCs. All of those hold heat. And so um, that's good because it provides us with a temperature range within which we can live. Um, when we talk about global warming or global climate change, what that essentially is an anthropogenically enhanced greenhouse effect, if you get what I mean. So the greenhouse effect, I want you to understand, is normal. It's good because it's a natural process that holds heat that provides us with a range of temperature that we can survive in. The only problem is we've changed the amount of some of these gases, actually all of these gases in the atmosphere. So when you have more CFCs and CFCs and more CO2 in the atmosphere, then you're going to have more heat holding. And so that's an enhanced greenhouse effect or an anthropogenically caused, or I guess, yeah, enhanced greenhouse effect. So it's similar to eutrophication in the fact that eutrophication is a natural process and that cultural eutrophication is enhanced eutrophication due to the unsustainable practices we do that make it occur faster. Same application here. Greenhouse effect is natural. Um, we have enhanced it though through unsustainable practices using energy, natural resources, and unsustainable land use practices. So as a result of those actions, this greenhouse effect has been enhanced since the start of the Industrial Revolution. The other thing is the ozone shield, and this filters out the most harmful ultraviolet radiation. We've already talked about that. Another cool thing about the stratosphere is the fact that that's pretty much the area where we fly planes, and that's because it's so thin. There's not a lot of matter up there except ozone. So as a result, they get better gas mileage, better fuel efficiency when they fly in thinner air. When I say thinner, it just means it doesn't have all those gases in it. It just has maybe one or a couple others. So you can see here in this diagram, there's a little airplane, and it's pretty much flying in like the lower part of the stratosphere. Again, both of these are necessary for life to exist on the Earth, but we have enhanced both of these actually so that and affected them in ways that we never thought we could. I'm going to stop right there because I think I'm running out of time. Okay, that's it with flip 1 for chapter 17 and 18.